Assalamualaikum warahmatullahi wabarakatuh. Hello everyone. So today I want to explain about TiO2 photocatalytic concrete self-cleaning and air purifying technology for sustainable civil infrastructure. But before I start, let me introduce myself first. My name is Desrania Miranti and my student ID is O22202500065. And I want to ask you guys something. Have you ever seen a building that stays super white or super clean after years that exposed to a pollution and rain? Or have you ever imagined what if concrete could actually clean the air around us? Well, surprisingly, the technology has already exists. Today, I will explain about it. Okay, so the next slide. Introduction. The concrete is one of the most widely used construction materials in the world because it has first, high compressive strength, good durability, easy application, and relatively low cost. However, modern urban infrastructure contributes significantly to environmental pollution. This concrete can purify surrounding air, decompose pollution, clean its own surface, and improve sustainability in civil. Traditional concrete only function as a structural material and cannot actively reduce pollution. So, what makes this concrete special is it can clean itself and help purifying the surrounding air around us. So next slide. What is TiO2 or titanium dioxide? So titanium dioxide is a semiconductor metal oxide widely used as a photocatalyst. So, the chemical formula written by TiO2 and the chemical structure looks like this. And the characteristic of TiO2 is white crystalline powder, chemically stable, non-toxic, corrosion resistant, inexpensive, and highly reactive under UV light. TiO2 is preferred because it is safer for humans, more chemically stable, better durability in outdoor, and environmentally friendly. So we continue to the next slide. The crystal structure of TiO2. As you guys can see, TiO2 has three main crystal phases. The first one is anatase. It is highest photocatalytic activity, most commonly used in concrete, and rutile, more thermally stable, lower photocatalytic efficiency, and brochite is the less common and difficult to synthesize. So why we choose anatase? It is because has a better electron mobility, larger active surface area, and lower electron hole recombination. So this means it can produce more reactive radicals. So we continue to the next slide. What is photocatalysis? The photocatalysis is a chemical process accelerated by light energy in the presence of a catalyst. In TiO2 concrete, the sunlight acts as an energy resource and TiO2 acts as a photocatalyst. So you guys can see the picture. When UV light hits TiO2, electron absorb energy and then electron become excited and then it can the reduction. And you guys can see the main reaction is TiO2 plus heavy becomes electron minus plus H plus, where heavy stands for UV light energy, electron minus is excited electron, and H plus is positive hole. When UV light energy exceeds this band gap, the electrons jump to conduction band, holes remain in the valence band, and TiO2 works because it is a semiconductor. And we continue to the next slide. Formation of electron hole pairs. So the photocatalytic process begins with electron hole generation. The first one is excited electron that move into the conduction band. This electron is participate in reduction reaction, reacts with oxygen molecules, and number two is positive hole. Holes remains in the valence band. So you guys can see the formation of reactive radicals, hydroxyl radical formation. This is H2O plus H plus become OH plus H plus. and superoxide radical formation is O2 plus electron minus became O2 minus. And why radicals are important? Hydroxyl radicals, it is extremely reactive, strong oxiding agents, and capable of decomposing pollutants rapidly. And we continue to the next slide. It is how TiO2 concrete clean itself. Okay, as you guys can see in here, the step 1 is UV light hits TiO2. When sunlight containing UV radiation strikes TiO2 particles, the semiconductor becomes activated. So the main reaction becomes TiO2 plus Hv become E minus plus H plus. The explanation is electron become more excited and electron hole pairs form, and then surface becomes chemically reactive. Okay, the step 2 is the formation of reactive radicals. So the electron hole pairs, it will react with oxygen, moisture, and also water vapor. And these radicals are highly unstable and extremely reactive oxiding agents. So it will form a hydroxyl radical formation and superoxide radical formation. And the step 3 is decomposition of dirt that radicals attack organic contaminant concrete surface such as oil, smoke residue, algae, bacteria, also dust, and also organic stains. Then we simplified the oxidation process. It will become organic pollutant plus OH become CO2 plus H2O. And the pollutant are oxidized into carbon dioxide and also water. Okay, we continue to the next slide. Step 4 is superhydrophilic surface. After UV activation, TiO2 surface become superhydrophilic. It means water spreads evenly and water forms thin sheets instead of droplets. So this is why the concretes become self-cleaning without manual cleaning. And also why TiO2 can clean air around us, because has that air purification mechanism. So I will explain. The same radicals also react with air pollutants around the concrete surface. The main pollutants we know that NOx, SO2, and VOCs. This is very dangerous, and we take an example of NOx removal. That vehicle emission produce nitrogen oxides. These gases are dangerous because they causes smoke, acid rain, and also respiratory disease. So when we combine the hydroxyl radicals oxide nitrogen oxidized, it will become NOx plus OH become NO treatment. So the result is harmful nitrogen oxides converted into nitrate ion. So nitrate dissolve in rainwater and wash away from surface. So this is what happen and surrounding air become cleaner. Why this reaction is possible? Because TiO2 acts as a photocatalytic, meaning accelerate chemical reaction using light. Catalytic itself is not consumed, so TiO2 can keep working repeatedly under the sunlight. Okay, we continue to the next slide. It is the methods of applying TiO2. TiO2 applied as a surface coating, that applied as thin film, spray coating, and also surface layer. The advantages is high photocatalytic efficiency and direct UV exposure. And the disadvantages is coating may wear off, long-term durability, and number 2 is internal mixing. Nano TiO2 mixed directly into concrete. The advantages is longer surface life, integrated inside matrix, and disadvantages is more expensive, may reduce workability. Okay, we continue to the next slide. The effect on cement hydration. Influence on cement chemistry is nano TiO2 affect hydration behavior of cement. Although TiO2 does not directly react chemically with cement hydration product, it acts as nucleation site and nanofiller. As you guys can see, here is the hydration reaction. And next, we talk about the advantages. The first one is environmental advantages. It reduces air pollution, remove NOx gases, decomposes VOCs, and support sustainable construction. The second one is engineering advantages. It's self-cleaning surface, lower maintenance costs, aesthetic durability, improve surface quality. And the third is chemical advantages. Is the catalyst reusable, TiO2 not consumed during reaction, strong oxidation, biological advantages, active antibacterial properties, prevent algae growth and inhibits microorganisms. The disadvantages is high cost, nano TiO2 production is barely expensive, and UV dependency. Photocatalysis requires UV light, so indoor performance becomes weaker. And also the workability reduction, this can reduce slump and complicate casting process. And also the fourth one is agglomeration is exclusive nano TiO2 that cluster together, reduce efficiency and weaken dispersion. Next slide, it is the case study. So the case study we took in Jubail Church, Rome in Italy, one of the most famous real application of TiO2 photocatalytic concrete. The church was designed by Richard Mayer and completed in 2003. When the sunlight strikes the TiO2 surface, this TiO2 plus Hv becomes E minus plus H plus, and these radicals decompose organic dirt, break down pollution, and destroy microorganisms. So the surface also becomes super hydrophilic, and rainwater spreads evenly and washes dirt away. The result is the church remain bright white, reduce surface staining, and also lower cleaning maintenance. And also, it proved that this is self-cleaning and concrete can actively reduce pollution. So we continue to the conclusion. TiO2 is an innovative construction materials that combine chemistry, nanotechnology, environmental engineering, civil engineering, that through this photocatalytic reaction activated by UV light, these radicals are capable of decomposing organic dirt, destroying microorganisms, and oxidizing harmful air pollutants such as NOx and VOCs into less harmful compounds. As a result, TiO2 concrete can perform two important functions simultaneously, and this is become self-cleaning and also air purification. Real-world applications such as the Jubil Church demonstrate that photocatalytic concrete is not only a laboratory concept but also a practical sustainable technology for modern infrastructure. However, several challenges still exist, including high material costs. It is depends on the UV light and also reduction on efficiency over time and also potential nanoparticle safety concern. And lastly, this is from a study case and journal. I take the reference. Although there are still challenges, this technology has strong potential for sustainable infrastructure in the future. So thank you for watching and see you.